Volcanoes. These formidable geological phenomena have captivated human imagination throughout history. Today, we'll embark on a detailed exploration of volcanoes, encompassing their formation, categorization, eruption dynamics, and the profound repercussions of their activities. We'll also discuss various volcanic hazards, monitoring techniques, and the endeavors to mitigate their potential harm to human civilization. Volcanoes take shape as a result of the dynamic interplay of Earth's tectonic plates. Plate tectonics are fundamental in the creation of these fiery giants, as they converge, diverge, or slide past each other. The flow of molten rock from the Earth's mantle, known as magma, plays a pivotal role in volcanic formation. The composition and characteristics of this magma are diverse, leading to a variety of volcanic manifestations. The pathways of magma to the Earth's surface can be complex and are influenced by factors such as pressure, temperature, and the presence of gases. The classification of volcanoes serves to define their characteristics and features. Eruption-style-based categorization includes shield volcanoes, stratovolcanoes, and cinder cone volcanoes. Each type has distinct attributes, and real-world examples help illustrate their differences. Alternatively, volcanic classification by location takes into account factors like their presence underwater, on islands, or on continents. The distribution and geological importance of these volcanoes provide insight into their role in shaping Earth's surface. Volcanic eruptions vary widely in their intensity and consequences. Effusive eruptions are characterized by the relatively gentle release of lava, whereas explosive eruptions are marked by their catastrophic power. Notable historical eruptions, such as the eruption of Mount Vesuvius in 79 AD, provide vivid examples of the dramatic impact of explosive volcanoes on human history. Volcanoes wield significant geological, climatic, and ecological influence. Their eruptions give birth to new landforms, shape landscapes, and generate features such as calderas and lava plateaus. Moreover, volcanic emissions, including gases and aerosols, affect Earth's climate. Volcanoes have played a role in past climate changes, and their eruptions can have far-reaching consequences for ecosystems and biodiversity, even causing mass extinctions. The hazards emanating from volcanic activity are divided into primary and secondary categories. Primary hazards include lava flows, pyroclastic flows, and volcanic gases, which directly threaten human and animal life. Secondary hazards like lahars, tsunamis, and ashfall pose additional risks to communities residing near volcanoes. Understanding these hazards is crucial for the safety of vulnerable regions. Lava flows and pyroclastic flows are two distinct but equally formidable volcanic hazards. Lava flows are the slow, molten streams of magma that make their way down a volcano's slopes during an eruption. These flows can vary in speed, with some advancing only a few meters per hour, while others can move more swiftly. Despite their relatively slow pace, lava flows can engulf anything in their path, including homes and vegetation, and pose a significant challenge for communities near volcanoes. In contrast, pyroclastic flows are fast-moving, scorching avalanches of hot gases, volcanic ash, and rock fragments. These flows can reach speeds of hundreds of kilometers per hour and are associated with explosive volcanic eruptions. Pyroclastic flows are incredibly lethal as they can sweep across vast areas, incinerating everything in their way and leaving behind a scorched landscape. Surviving a pyroclastic flow is exceedingly difficult, making early warning systems and evacuation plans of paramount importance for safeguarding human lives in volcanic regions. Volcanic tsunamis, also known as tsunami-generating eruptions, are a perilous consequence of volcanic activity, particularly when underwater volcanoes are involved. These tsunamis are triggered by events such as explosive eruptions, caldera collapses, or underwater pyroclastic flows, which displace large volumes of water, creating powerful waves. Volcanic tsunamis can propagate rapidly across ocean basins, often with devastating consequences for coastal communities far from the eruption site. The infamous 1883 eruption of Krakatoa in Indonesia generated one of the most notorious volcanic tsunamis in history, causing massive waves that killed tens of thousands of people across the region. Understanding the potential for volcanic tsunamis and implementing effective warning systems is essential to mitigate their catastrophic impact and protect coastal populations from these destructive events. Lahars, also known as volcanic mud flows or debris flows, are highly destructive and deadly volcanic hazards. These fast-moving mixtures of water, volcanic debris, and sediment can occur during or after a volcanic eruption, and they pose a severe threat to communities living in volcanic regions. Lahars are often triggered by heavy rainfall, the melting of snow and ice, or the breaching of crater lakes, which can mobilize loose volcanic material down the slopes of a volcano at astonishing speeds, resembling a powerful, turbulent river of mud and debris. Lahars can travel great distances, burying towns and infrastructure, and their impact can be devastating. Understanding the potential for lahars and implementing monitoring systems and early warning mechanisms are crucial steps in mitigating the risks associated with these hazardous phenomena. Ashfall is a common and widespread volcanic hazard that occurs when a volcano erupts, expelling fine ash particles into the atmosphere. These airborne ash particles can travel great distances, depending on the eruption's intensity and prevailing winds, and eventually settle to the ground. Ashfall poses a range of problems for both the environment and human society. It can smother vegetation, contaminate water supplies, disrupt transportation, and cause respiratory issues when inhaled. In addition to immediate consequences, ashfall can also damage infrastructure, including buildings and vehicles, and create long-term challenges for cleanup and recovery. Volcanic eruptions that result in significant ashfall require careful monitoring and effective public communication to ensure the safety and well-being of communities in the affected areas. The monitoring of volcanoes relies on a range of specialized instruments and techniques, such as seismometers, gas sensors, and remote sensing technology. These tools help in predicting volcanic eruptions and providing early warnings. Successful monitoring and alerts have saved countless lives, as evidenced by case studies of well-executed predictions and evacuations. Mitigating volcanic hazards involves strategic land use planning, including zoning regulations and building guidelines for areas near active volcanoes. Furthermore, the establishment of evacuation plans and preparedness measures is essential to safeguard human lives. International cooperation, as exemplified by organizations like volcano observatories, plays a vital role in reducing global volcanic risks. Collaborative efforts are instrumental in sharing information and coordinating responses to volcanic threats. Volcanoes are both wonders of nature and potential sources of disaster. A comprehensive understanding of their formation, classification, eruption mechanisms, and impact is indispensable for scientific exploration and the protection of human populations. Through vigilant monitoring and international collaboration, mankind can coexist with these geological giants and minimize the devastating effects they may unleash.